So now in this video we will be discussing on OSPF LSA types. Okay, so that is the main topic. So in the previous videos we have seen the OSPF design implementations using multiple areas, OSPF virtual links, and then the behavior of the OSPF in broadcast networks. So now we are into the last part of the OSPF where we'll be discussing more in detail on LSA types. Now in this video we'll be discussing on different LSA. LSA stands for link state advertisement. The meaning is it's a normal advertisement which happens in OSPF process. So there are multiple LSA types. You can see the table here which defines LSA 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you got many types of LSAs. So majorly we'll be discussing around 7 LSAs which are the most common LSAs, not LSA 6, because LSA 6 is a multicast OSPF. I'll get into this individual LSAs. Whereas LSA 8, 9, 10 level are generally very advanced LSAs, where we can say LSA 8 used in external attributes in BGP, and some LSA 9, 10 level, generally we call them as opaque LSAs, which are used in MPLS traffic engineering in some advanced implementations. So we'll be discussing, as per our CCNP, we'll be discussing on 7 LSAs. So probably the main LSAs, we can say the first 5 LSAs are the main LSAs which are used. So when you refer some documentation, Cisco docs or any other Cisco Press books, when you'll find a lot of theory covering these LSA types. So I'm going to make a little bit simplification of these LSA types, and we'll try to understand what is exactly LSA. LSA is just an advertisement, and we'll try to understand when and how these LSAs occurs and how it happens. Okay, so I got a simple diagram here. So first we'll be starting with LSA 1. So I'll be starting with LSA 1 here. The first type of LSA I can simply say as LSA 1. So LSA 1 is a normal LSA which happens within the area. Within the area means one router advertising to other router within the area. We call it as LSA 1. So if you just take the diagram here, so I got some diagram, very simple diagram here. I got 3 areas, area 20 connecting to area 0 and connecting to area 10. So I got 3 different areas. This is one area, area 0, area 20 and area 10. And also I got some external routes. External routes nothing but the routes which are learned from other than OSPF protocol, and they are getting redistributed into the OSPF. So these are external routes. These are, we can say, redistributed routes. So we did some redistribution classes also. So we know how to do redistribution between different routing protocols. And the router which is doing redistribution, we call it as autonomous system border router. So this is your ASBR router which is redistributing the routes into OSPF. And then these are your area border routers, you can see ABR, which are actually connecting multiple areas. So here I got very simple diagram with 3 areas and the routes coming from EAGRP, or it can be RIP, whatever the routing protocol. Okay. So LSA 1 is a normal advertisement sent by one internal router to another internal router. So if I take an example here, so this is the router. This router is having some network called 10 network, let's say. Assume that this is a network called 10 network. Now this router is advertising its own network to some other router inside the same area. So let's take an example, there is one more router here. So it's advertising to other router inside the same area. So we call this as LSA. The link state advertisement, nothing but the normal advertisement, but we call it as LSA 1, which means any router informing to any other router within the area, means the advertisements which are happening within the area, we call that as LSA 1, and generated by the internal router. One internal router informing an update to another internal router, sending an update to another internal router. So it can be any link, it can be a point-to-point link, or it can be HDLC link, PPP link, or HDLC link, or it can be Ethernet link, whatever the type of connection you have in between the links. So I got some notes very much in detail. It says generated by the internal router, LSA 1. So it is going to advertise to every router inside the area. So it also includes some more information apart from network. It also includes some network information as well as IP prefix and whatever the network type. Link type means it can be Ethernet or PPP, HDLC, whatever the type. So when it advertising the any network like 10 network, it also advertises this information along with that update. So it floods within the area. So it floods within the area means this update will be sent only within the area. It will not go outside the area, which means, so now this router is advertising 10.network to another router inside the area. So similarly, this router advertises to other router inside the area. This router advertises to other router. So the advertisements whichever happens inside the area, and only internal router is advertising to another internal router, we call that as LSA1. Okay, LSA1 is a normal advertisement generated by the internal router, one internal router informing to another internal router. Okay, so we call those as LSA1. Okay, so generally we can say O routes. If you remember routing table, O routes represents the routes coming from the same area, which means whatever the advertisements happening inside the area and generated by any any internal router, we call them as O routes. So output wise, when you show IP route OSPF, you'll see them as O routes. So they are flooded within the area and they do not cross the area border router, which means whatever the advertisements happening inside the area, it can be any area, it can be area 20 or it can be area 10 or it can be area 0. So any advertisement happening within the area, we call it as LSA1. So we can say this router advertising to this router, generally we can say it as LSA1. Okay, so similar way we got another LSA, LSA2. Generally technically we call it as network LSA. So DR informing to other routers. So if you remember, in the previous sessions we discussed something called DR BDR elections in the broadcast networks. So whenever you are connecting any network, you have a routers connecting to a broadcast network. Broadcast network means Ethernet network, so where there is a possibility of broadcast. So whenever you will see this type of networks, like I got one network here, router connecting to an Ethernet switch here, and again it is connecting to some other routers. So in case of broadcast networks, there is something called DR BDR elections. So DR BDR elections is actually a loop prevention mechanism. So they will elect any one router as a DR, designated router. So if any router is having any update, they have to send to the DR. So assume this is the DR and assume this is your BDR. BDR nothing but backup designated router. Okay, so in this type of scenarios where you have a broadcast network and where there is a DR BDR elections, so assuming this is your DR designated router, assuming this is your backup designated router, so there is an update. So this router receives an update and it is going to inform that update to the DR. So once the DR receives that update, the job of the DR is to make sure that it sends to other routers inside the same network. So it is going to inform to other routers inside the other routers. Generally we call it as LSA2. LSA2 is also same like LSA1. It's a normal advertisement generated by the internal router. Okay, and generally generated by the internal router. It also referred as O routes. So when you compare LSA1 and LSA2, both are similar. It's almost same except one difference. The difference is when you have a DR BDR elections in the broadcast networks, it is sending the update to other router other than DR BDR. This type of advertisement we call that as link state advertisement to LSA2. So technically we call it as LSA2. Okay, so that is a basic difference. This is the only difference. So normal advertisement means if you are using a point-to-point link, there is no DR BDR. If you are using HDFC link, there is no DR BDR elections. So there is only LSA1. So when you have DR BDR elections, an update sent by the DR to other router, we call it as LSA2. Okay, so LSA1 and LSA2 both are the updates are advertisements which are sent only within the area. Means whatever the advertisements happening inside the OSPF inside the same area can be LSA1 or can be LSA2. So now coming to LSA3, the third option. Now LSA1 we have seen, LSA2 also we have seen, LSA2 also the same. Only the difference is the DR sending the update to other. Generally we call it as LSA2. So now when we talk about LSA3, LSA3 is something generated by the area border router. Now who will generate this advertisement? Area border router informing about the routes from one area to another area, exchanging the routes between the areas. So now in general, if you remember the process is very simple in OSPF. So whatever the advertisements happens, like take an example here. So now this router receives some updates, it will send to this router, every router will participate in the advertisements. So all the routers inside the same area exchange the routes in the form of LSA1 or LSA2, right? That's what we discussed just now. Each router updates every other router inside the same area in the form of LSA1 or LSA2, normal advertisements. Now, even the border router also will participate and receive the advertisement from these routers, all the routers from the same area. Now, what is the job of this border router? Border router is a router which is connecting both the areas, and this border router is responsible for exchanging the route between the two areas, right? That is the job of the border router. So now border router is going to receive all the routes or all the advertisements from one area in the form of LSA1, LSA2, and then it is going to send the same update from one area to another area. And when it is sending the updates, exchanging the route between two different areas, we call those type of advertisements as LSA3 advertisements, link state advertisement 3. I think technically we call as summary LSA. So we call it as summary LSA. Summary LSA is, you can see here, this diagram will give you some clear idea. There is a area border router, there is a area 1, there is area 0, and the area border router is exchanging the routes between the two different areas. So my diagram will give some more clear idea here. You can see this. So this is the router which is responsible for exchanging the route between them. So border router, we learned in the basic OSPF process that border router is going to maintain the database of both the areas. The border router is going to participate in the algorithm of both the areas, and also border router is responsible for exchanging the route between the two areas, right? Now whatever is exchanging, they generally we call those type of advertisements as LSA3 advertisements. So the same case happens between these two areas, any two areas. So I'm not specifically saying it is between area 0 and area 20. It can be between any two areas. Okay, so now LSA1 and LSA2 advertisements happens within the area, and now they are exchanged with the different area in the form of LSA3. So next type of LSA we need to understand is LSA4, the fourth type of LSA. So LSAs is simple, basic theory topic we need to understand. It is a little bit useful, especially when you face interviews and technically you'll be tested on this LSA types understanding. So if you find documentations, books, you'll find them written in a little bit more complicated way. So but these are actually very simple, just you need to understand the advertisements. So there's no much practical into it. It's all about theory we need to understand. Now LSA4 is also generated by the area border router. So which means LSA4 is generated by the area border router, means LSA4 will generate these messages, but there is a difference between LSA3 and LSA4. LSA3 is something which is exchange of the route between two different areas, but LSA4 is also an advertisement which is going to advertise the information about who is autonomous system border router. So I'm just using my simple terms for understanding in simple instead of using technical terms. LSA4 is going to advertise and saying that who is autonomous system border router. So now if you remember, we learned something called ASBR. ASBR is nothing but autonomous system border router, the router which is responsible for, which is doing redistribution of external routes. External routes means it can be EHRP, it can be RIP, it can be BGP, any other protocol other than the native protocol. Native protocol is OSPF here. Redistributing them into the OSPF. That router we call as ASBR router, autonomous system border router. So assume this autonomous system border router name or router ID we can say is F. It can be any name. So let's say this is 11.1.1.1. Assume that is the ID, router ID of ASBR. So now this border router is going to inform to all the internal routers saying that the information ASBR is F, means the ID, or we can say ASBR is 11.1.1.1. So the border router is going to advertise to all the internal routers how to reach external routes, or who is autonomous system border router and who is actually doing redistribution of external routes into OSPF. Okay, so that's what this LSA4 advertisement tells. LSA4 advertisements provides the information of autonomous system border router. So we call it as summary LSA. LSA3, LSA4 is not summary LSA. Just a minute. Let me. So LSA4 is used to advertise the ASBR information to all the other areas inside the autonomous system. Means nothing but inside all the OSPF. So they are actually generated by the ABR router, and they are regenerated by the subsequent ABRs and flooded throughout the autonomous system number. So which means, so from this diagram you can see here, I can explain you a little bit more better. So you can see the diagram here. Here, as per this diagram, you have some external routes. External routes means the routes which are coming from RIP, EAGRP, and this is your ASBR router. So ASBR is advertising external routes to normal router. Normally, it's advertising to some other router here. Now, once these routes are coming from here, reaches the border router. So in our example, this is not the border router, this is the internal router. So it will not generate LSA4. So these routes reaches the border router. So this border router is going to advertise to other routers saying that who is ASBR information. This is your ASBR and it is called LSA type 4. So every router, which means it will address this information to all the routers inside the same area. Also it will address to other side border routers. So now this border router is again regenerating the same message to other routers. So it will go on to another area. Similar way it will go to other area. Like that, whatever the number of areas you have, it will subsequently move on or regenerated by every border router inside the area. So we call this as LSA4 advertisements. Okay, and then finally we have something called LSA5, which is again LSA5 is generated by autonomous system border router, which means who will generate these LSA5 messages? LSA5 messages are generated by autonomous system border router. So this is the border router, ASBR router. So it is going to receive the routes and then redistribute them into the OSPF. So generally whatever the routes or whatever the advertisements or whatever the messages relating to external routes getting redistributed into the OSPF, we call them as LSA5. So technically we call them as OE1, OE2. If you remember, we did in redistribution. OE1, OE2 represents external routes. If you remember, we have seen O types routes. O routes nothing but the routes coming from the same area. If you remember the outputs, when we did OSPF labs, we'll see different types of outputs like O routes, OIA routes, and also we'll see OE1 or OE2. So the routes coming from the same area will be listed as O routes, and when we see the routes coming from a different area means we are in area 0. So if you are receiving the routes from area 10, you'll see them as OIA routes, nothing but OSPF inter area routes, nothing but the routes coming from a different area. And if you see something called OE1, OE2, so maybe when we did redistribution labs, we have seen this type of outputs. So nothing but these, generally we call them as external routes. External nothing but the routes are learned from other protocol other than OSPF like RIP, EAGRP, but they are redistributed into the OSPF. Okay, so technically we call them as LSA1 routes or LSA2 routes, technical names. So anyone says LSA1, LSA2 routes means you have to understand the routes from the same area. And anyone say LSA3 routes, you have to understand the routes coming from a different area. So technically we call them as LSA3 routes. And external routes are technically called as LSA5. So LSA5 routes means you have to understand these are the routes coming from different routing protocol and getting redistributed into the OSPF. So this is the final summary which I really suggest you to remember. It's very simple. You don't need to get into much detail on these things, because when you read some documentations you'll find much complicated languages, technical terms used, but this is the final summary what exactly LSA defines. O routes from the same area, OIA routes coming from from inter-area routes, nothing but from a different area, and LSA5 represents. So you don't have any LSA4 types of routes, so probably LSA5 you can see them. So because LSA4 is not, you don't see exactly routes, it's actually information. LSA4 provides information about autonomous system border router. Okay, so let me just quickly give some idea on LSA6, which we don't use in general. LSA 6 is not used because LSA 6 is actually used when you are using multicast routing. Generally we call as MOSPF. There is a routing protocol. When we do multicasting, there are some multicast routing protocols like PIM, sparse mode, dense mode protocols. Okay, so it's beyond the scope of your CCNP routing switching syllabus, but just a basic idea. So we call it as multicast LSA, which Cisco routers doesn't support. So Cisco routers doesn't support this protocol, so we don't use this protocol in Cisco routers. So the most commonly used protocols are PIM, sparse mode, dense mode protocols. So we don't really get into this LSA 6, and also there is LSA 7, which is used in NSSA updates. We'll be seeing in our next session relating to that LSA 7. So LSA 8, 9, 10, 11, these are all opaque LSAs, which are a little bit more very advanced LSAs used in advanced optimizations like MPLS traffic engineering in that options and some BGP implementations. So as per our CCNP routing switching, we'll be discussing the 7 LSAs. In that 6 we don't really use them. So the 1, 2, 3, 4, 5 LSAs we have discussed now. Probably 7 LSA I can't explain you right away without understanding this stubs concept. So probably we'll be discussing stubs, totally stubs, not so stubs, and then you'll get some better understanding. Once we discuss those things, then again I'll explain you that LSA 7 as well. Okay, so router 1, LSA 1, 2. Let me quickly summarize all the LSAs. So LSAs, so I'll draw the diagram here. I'll explain you one more time quickly what exactly we need to remember regarding the LSAs. Okay, so you can find some technical terms used in my document, and also, but that is good to know. At the same time, you should have a very simple understanding on different types of LSAs. Okay, so LSA 1 and LSA 2, generally the LSAs which are within the area, which means one router advertising an update to another internal router, but as long as it is not going outside the area, we call it as LSA 1. Okay, so one router informing or sending an update to another internal router. So one router sending an update to another internal router, we call it as LSA 1. Okay, so LSA 2 is an LSA where you have DR/BDR elections. You know, DR/BDR elections happens when you have broadcast networks, and in that DR/BDR elections, when the DR receives an update and it is going to send the update to another router other than DR/BDR, nothing but sending it to other routers, we call this as LSA 2. So in simple, I can say LSA 2 happens when you have a broadcast or non-broadcast networks where there is a possibility of DR/BDR. So LSA 1, LSA 2. You can see LSA 1, LSA 2, they are only within the area, so they don't really go outside the area. So in simple, I can say LSA 1 and 2 are generally O routes, the routes within the area. But now once this border router receives all the information within the area, it has to make sure that it sends outside the area, nothing but it has to send to other area also, and that type of advertisement we call it as LSA 3, the link state advertisements. So which is technically output wise, we'll see them as OIA routes, the routes coming from a different area. So the routes exchange from different areas, we call them as LSA 3 routes or LSA 3 update. Now LSA 4 is the information provided by the border router to other routers, informing about the information who is ASBR. ASBR is F. Let's give some name for ASBR. It can be any name. Generally, the router ID is a name. So this is the information provided to all the other routers within the AS. Autonomous system means this is what we call as autonomous system. Autonomous system means the region where you are running the same common protocol. So within my company, we can say. That's what we call as LSA 4. And LSA 5 is technically we call them as external routes. The routes getting redistributed into the OSPF, we call them as LSA 5s. And output wise, you'll see them as OSPF, external route type 1, external route type 2. So this type 1, type 2 also we have seen, we are discussed in OSPF redistribution topic. Okay,